It is my pleasure to introduce Rong Chen. He is a dear friend. He is an internet pioneer. He is a Web3 visionary, and he has probably the most unrivaled path through the existence of the internet, from supercomputing all the way to building out and founding one of the most influential Web3 platforms and products, Elastos. So today, we're going to go through his history. We'll touch on that early on and then try and talk about specifically Web3 towards the end. And before we begin, I want to highlight a few of the milestones throughout his career that I think are worth noting. One is that he was working with supercomputers early on, and some of that development research went on to helping to build out one of the first web browsers, Mosaic. Also, he had a term at Microsoft Research and was one of the first 10 employees of Microsoft Internet Explorer team, which is amazing. And also, he's gone on to work and build out the vision for Elastos and Web3. So the span from the beginning times of the internet until now, that's Rong Chen's history, and we're going to dive into it here. So let's unpack it and start around the infamous class of 77. Can you tell us quickly about that? Who was a part of this? And I'd like everyone to understand kind of where you came from.
Thank you, Donnie. The class of 77 was, a special class in China because of there was a cultural revolution, which closed down all universities from 1966 to 1976. So class 77, actually that was the entrance year, was the first class after the Cultural Revolution. Before that, actually, I was a city kid, grew up in Beijing, but I was sent to a farm as a labor, basically a pig farm. Then I took national exam from the farm and had the opportunity to enter Tsinghua University computer science.
Yes, and that's pretty amazing. And I wanted to start there because you are very humble, anyone that knows you, and I think that you have done so much in this space and you have such a deep passion for it, and I think that it starts there. So we'll quickly jump forward to coming to the United States and working at Microsoft Research. Well, actually, let's go back to your work on supercomputers. So UIUC, if you want to touch on any of that, I'd love to hear more about that time.
Oh, yeah. Well, I wouldn't say I was the pioneer. All I could say is just a fluke. I was there, right? Literally true. Before I came to the US, actually after graduate from university, I went to a lab called Lenovo lab, when the lab had only like 5 people, right? But then at that time, I got the scholarship to study abroad in the US. I didn't pay attention what my colleagues, the team was doing, right? They were doing Chinese input-output cards. I just happened to be there. And later on, of course, everyone knows what Lenovo is right now. But at that point, with 5 people in the lab, right, and 2 grad students, nobody, at least me, I didn't see the future of it, right, doing peripheral cards. And I was kind of like darting off the team and saying, oh, Ron, what a lucky guy. And you could go to the US, we couldn't. But after I left the lab, after I left for US, 3 months later, the Lenovo was founded, right? So I didn't do anything, but I was there, saw, the bleak future, right? How humble, how everybody was.
Yes.
And similarly, when I was, of course, I went to University of Illinois, lucky enough, and I was trying to look a job for summer internship because coming from a poor country, I need some scholarship, pay my tuition. So I found a job at the National Center for Supercomputing Applications. But then at that time, I didn't really like to program for those astronomy professors or physics professors. So it's just a poor job, right? Got paid.
Mm-hmm.
But turned out later on, the supercomputer we used, because those professors need to crunch out data on two supercomputers, two crays. And then we need to render the data on PCs, Macintosh, and Sun workstations. So that's happened to be later on realized that was the very first web server and the very first clients that we were working on. We even have to, some fellow students have to write TCP/IP on PC for the first time.
Mm-hmm.
And I and another colleague of mine, we did the visualization, basically doing multiple windows and render the software, drawing the contours, pseudo color, and the 3D graphs on the screen, which then later on, of course, the company took the software, open source software, and founded a company called Spyglass. Because of the name Spyglass come from multiple windows showing different renderings of scientific data.
Yeah.
And that company happened to own all the web patents from the beginning, like Mosaic and HTTP.
Mm-hmm.
All those patents were owned by Spyglass, and I didn't know that, and I didn't pay attention.
Yeah. Well, you say that it was lucky that you were there, but I feel like you being there is much more influential than you say. So I think that time is amazing to be there as a first for many of those things. So let's jump forward to Microsoft, joining the team, being one of the first 10 Internet Explorer team. I think you were one of the first hires for Microsoft Research from China. So let's dive in there.
Yeah, I was working on Research OS from like 92 to 94. We were doing, we invented our own interactive TV kernels and doing interactive TV, right? Set up a server farm as early as like 93, 94. Spent like millions of dollars with PCs as servers. And also we had the client software running on set-top boxes and rendering those interactive TVs. But then as soon as Microsoft realized there's something called a browser, and made a wise decision at that time to go bet on the web technology, right? So I moved from the interactive TV team to the browser team, and happened to be the number 10 employee of the IE doing ActiveX for those widgets, or for those Java has this so-called Duke, a waving hand animation character, and we have to do something to compete. So that was how we got to I got involved with the IE. And I also happened to help building so-called progressive JPEG and rendering those JPEG picture from like a blurry to a fine pixel-wise, right? It can display the whole clear picture. Yeah, I happened on that front as well.
Just a side question. How amazing is it to you to see the difference today compared to what you were working with back then?
Well, again, at that time, I was very much kind of like an engineer-minded, and only thinking about how the software works, but I completely overlooked the web as a business opportunity, right? Because being number 10 employee of the web, you naturally think I would love to stay in the browser team and participated in the .com booming, right? But turned out I didn't, because I thought anyone with his dog can write a web page. What technology is there? And my passion was in the inner workings of how computer works. So I moved on to like Ole automation, .NET, basically keep down the operating system track instead of cut down on the internet tidal wave. I completely missed it. So anything I want to tell the audience is look at the big picture.
Yeah.
Because the thing is, since I was doing operating systems for life, how many times, how many chances you get to design or have contributions in the operating system, right? Mainframe, PC, cell phone, Metaverse. So basically what I'm saying is in 70 years of computer science history, there are only 4 chances to design a new OS. Right? That's how valuable or how pathetic, because if you happen to not to be in the catch on the tidal wave, then everything is going to be wasted. Because let's say you do BlackBerry OS, you do Symbian, you do Microsoft Windows Phone OS, right? Even though you have tons of money, you still won't get anywhere. Like for the web, we have internet in the early 80s for the public use. I mean, out of research. Internet was in the early 80s. The web 1 was in the early 90s, 95. And then Web 2 is about 2007, 2010, right? So unless you are right on the edge, like then you missed it. And if we're saying we're right now right on the edge of Web 3, whether you believe it or not, right? You can decide not to believe like me. I didn't believe web was a big thing when I was number 10 employee of the IE. I didn't think web was something huge, right? And that's the mistake I made.
Yeah.
But now I do see Web3 being another chance, right? Happen to have, let's see, a facts. Bill Gates, Steve Jobs, Tim Berners-Lee, Larry Ellison, founder of Oracle, and also Bill Joy, founder of BSD Unix and Sun Macro. All of them have one thing in common. They were all born in 1955.
And when were you born?
A little bit, a few years, 2 years later.
Just around that time.
But then because of I didn't speak English, I come to this country, a lot of handicaps, put it this way. But why everybody is born 55? Right? Basically, hero creates history, or history creates heroes. That's the lesson learned. If you're born 2 years later, you miss the chance. So that's how critical.
Let's just stop right there for a second and just think about that, because you're talking about some of these monumental opportunities we have in our life, and one of them being where we are today with Web3, with the metaverse, the way that we're changing the way that operate the internet. And I think that's amazing. So let's quickly go back to what you're talking about with operating systems. So you leave Microsoft, you go back to China. You're working on operating systems in China. I think you were very influential there, and some of the early operating systems developed. But this was at a time also whenever Apple and Google came out with their smartphones and their operating systems. So tell us a little bit about how that worked with what you were working on, how that changed with the presentation of this new technology.
Well, and again, a lot of people can write kernels, can write operating systems. It's not like just me or some other guys. Just happen to be the chances of succeeding is very rare. Like at Microsoft, at least 100 people can go off and single-handedly write a operating system. When I was at Microsoft, at least the people I know, right? To set up maybe 100 is a little exaggerating, but set up like 20 is definitely a low bar, Because at that point, when I was at Microsoft, 5 operating systems were in developing in parallel. 5. Let's say, a lot of people can go off and write another one, and just not that hard. The reason why I went back to China to create my own operating system was 2 things. One is I was in the .NET design team. I thought we could do it from a CPU level instead of from the intermediate language level. So basically, it's more down to the metal. And the real problem we are trying to solve is actually has an effect today. Who caused the viruses, right? If you see the internet has lots of viruses, network attacks, and security leaks, and so on. What are the solutions? Who is the culprit? And let's see, apps, the internet apps, all apps can open up TCP/IP sockets and send the data to wherever they want to send the data to, right? So let's say a word processing software opened up your Word document. Could the software send a copy, piracy copy, to its own backend server? Right? So basically, all apps are suspicious. No exception. So the most evil are apps. Apps could all potentially be evil. It's not just viruses. So how do we fend off the viruses? How do we prevent apps from stealing user data? We knew the answer 20 years ago. But why it's not fixed? I didn't know. I thought we could fix the loophole. But one thing I missed was that if we were going to fix the loophole, then the free internet, the whole internet will die because no one makes money. In a way, everyone was to blame. All developers, all companies were to blame for, in the name of big data, to steal user information. And if we could fix all the loopholes to prevent viruses, no ransomware, no viruses, then how could the IT industry survive? Those are the questions we didn't know the answer for. Even though we know how to fix the loopholes, but no one wants to fix the loopholes. That was the irony, the big lesson learned, right? Currently with the blockchains, so we have a tokenomics model. In a way, we can tax, internet can tax apps instead of Google's, Amazon's, and the Facebook's taxing, stealing user data. Can we have, it's like Wild West. Everyone can go to the West and get a piece of land to farm. But on the other hand, if you leave your farm, you are in the Wild West, right? You're going to be robbed. And are you going to have set up cities, or are you going to have infrastructures, the secure roads you can walk on? So those are the things until blockchain. We don't have a solution. That's why if we don't have a solution, then we cannot fix the loopholes. That was the problem.
Yes, exactly. And I think that's a great segue to where we're going to go now. So let's leapfrog to 2017, the emergence of Elastos. We take all this information and these firsthand experiences that you've had throughout your life building out operating systems, and whether luck or not, being there along this whole journey. And then your work meets blockchain. That's where Elastos comes in. I think we should spend the remainder of this time talking about this technology, the vision for Web3, and where we're going to take it next. So let's just jump in there real quick.
Yeah, actually, let's again, as I said, when I was at the internet, we should look at the bigger picture. So what's the bigger picture of Web3? A lot of people talk about Web3 from the crypto perspective. It's like me. It's like me when I look at the browser. It's just a piece of software. We don't see I don't see The future, right? Basically, you see a piece of software, you see crypto, you see zero proof, knowledge proofs, you see technology. But then a lot of people kind of start to believe, like a crypto projects or their investors. They believe, like, let's say hypothetically, there's money now, peer-to-peer money, right? Currency. Assume, we believe that. And then why do you need money? To set up a economy, you need to trade with goods. Otherwise, trading euros to dollars and dollar to RMB, it makes no sense.
Yes.
Right? So that's why a lot of internet veterans believe cryptos are a bunch of Ponzi schemers, but which is not. I'm full-heartedly believe in cryptos, right? But I do see from the internet veterans' perspective. And money trade with goods. What are the goods? The digital goods. No, not only we can use money to buy drugs, buy guns, but you can also use money to buy movies and buy ebooks, buy those virtual digital merchandise, right? We're talking about the Metaverse. What's a merchandise? There are two basic fundamental characteristics. There's a demand for it. There's a scarcity for a merchandise. If you go to any shopping mall, grocery store, you'll see a price tag, a barcode on every merchandise. Then there's this merchandise itself. So what's a NFT? NFT is more like the label, the barcode of the merchandise. What is that merchandise, right? If there's a demand, I need to breathe air, so I demand air, but then there's an ample of air everywhere I go, so then I don't pay for it.
Correct.
Then for scarcity, if we see how do we create scarcity, for thousands of years of human history, the Industrial Revolution especially, people try to improve efficiency to make more goods, like more cars, more phones, more everything, right?
Right.
But on the other hand, if you see digital goods, all digital goods born ample, born abundant. Everyone can make a piracy copy with almost no cost.
That's a good point.
So how do we artificially create digital asset scarcity? So then the digital currency can trade with the digital merchandise. So then we can have a cyber economy.
Yes, and I think everybody needs to think about what you just said there, because that's very, very important. That's something that's not touched on very often. So continue with that thought.
Because of until today, we don't really have cyber economy. People buy software services, right? They don't buy software goods.
Correct.
They don't buy software products. They buy product in the way they lease product. Let's say you buy an ebook from Amazon. You don't really own the ebook. You lease the ebook because you cannot give the book to someone else. You cannot resell ebooks. How can we make the digital merchandise a virtual goods? So not only we need a barcode, the scarcity NFT label on top of the merchandise. How do we prevent the merchandise piracy? In case of there's a piracy, how do we get rid of those piracy copies, like antivirus software? How do we, cleansing those piracy copies all over the Web3, right? So then we can have a cyber economy. There, not only we need the blockchain to generate the barcode, we also need the software runtimes or the network OS to find out piracy and to make sure that we have a cyber economy.
Yeah, and that's a great point, because it's not just the blockchain that's required for us to be successful in this metaverse, this Web3. And people need to understand that the way that's operating now, like you said, the Amazons, the Googles, the Facebooks, they own and retain inside their silo what they have. And Web3 is opening this up to everybody. So with Elastos that you founded, there's many components. It's not just a standard crypto project. There's a main chain blockchain. There's a way to obtain an identity through decentralized ID chain. There's storage, because you have to think about how you're going to store your data. There's a peer-to-peer network. There's smart contracts. There's so much to it. So that's why I think it's hard for people to grasp the extent of what Elastos is. And I think that by just listening to what you're saying here, going back to your history and how things have led to this starts to give an idea of where we're going to go next. So where do you think we're going to go next with Web3, with what we're building now that we're seeing the metas and people talking about Metaverse coming out? Where are we going to take this next?
Well, I think we have to really we have to be precise, right? So then we have a solid step we have solid steps along the way, instead of always iffy talks. What's a web, right? We have to think Web 1, Web 2, and Web 3. Basically, it's a continuation. Web 3 is a continuation of Web 1 and Web 2. And what is a web? Web, basically, it draws a spider web, right? It's just like dots and lines. Very, very simple. A kindergarten kid can draw a web, dots and connecting dots with the lines.
Yes.
And that's a web. Now the question is, for Web 3, what's the difference of Web 2, Web 3 web and Web 2 web, Web 1 web, right? So if you see the dots, we have new kinds of dots for Web 3. Web 1, Web 2, no individual servers. All servers belong to some institutions, right? And so if individuals want to get on the web, you have to dial into a website, so-called a portal. Now on Web 2, you have to get on the cloud, so then you can access the web. Actually, the phones and PCs are not on the web. But the routers, if you think of routers, it's powerful enough comparing to the early web servers, right? So can we have router-like devices to behave like personal servers? And secondly, all those nodes on the web belong to, again, institutions. Can we have a consensus, right, using blockchain to control a node? Let's say a Ethereum world computer or Definity internet computer. Can we use those consensus computers to work as a Web3 node? Well, I mean, one computer is not a web, but then the Ethereum, the Definities, they are special nodes for Web3. Very unique, very novel, but they are nodes. They are new kinds of nodes. And thirdly, the lines between the nodes. Can we have dynamically connecting arbitrarily two nodes on the fly, right? Like the carriers, AT&Ts, connecting two phones on demand. So then the information won't be able to leak out of the two phones and the virtual circuit. Basically, it's quarantine the environment, and no user data will leak out of the phones and the virtual copper wire between the two phones, right? So that's the topology of Web3. Then from that point on, you can imagine how we're going to build the future. We have to know where we start.
You can imagine, or you can't, because it's really hard to tell. It's hard to, like you said, whenever you're in it and you're trying to compare it with what we're doing today on the web, it is kind of hard to envision where we're going to go. But I think we were able to unpack a whole lot in this 30-minute talk. I think there's so much more to learn about Elastos, about your knowledge and where we're going with this. So I'm going to end it there. I'm just going to say that if people do want to follow along, you can be found on Twitter with it's Chen2 Rong2, correct? Is your username?
Chen2 Rong2. Yeah, just read my Twitter. I pretty much write everything I can think of on Twitter.
Yes, and I love it. It's you just come out with all this information all the time. So follow Rong on Twitter. You can find my thoughts on Twitter at Donald Bullers, and also follow Elastos. Elastos info. Go to elastos.org. Learn about what we're building. I think it's pretty amazing, and we have a lot left to do. Thank you.
Thank you, Donnie.